5.5 and 5.6 notes are going to be our third way to solve systems of equations. So your first one was graphing, your second one was called substitution, your third one is called elimination. So what this does is you add or subtract equations to eliminate, or I'll say cancel out, one variable. You will still have to solve for both variables, but instead of plugging in for one of the variables, you're actually going to eliminate it for your first step. So step one is to make sure your equations are lined up. So when we get further into the notes, you'll see how sometimes you have to first move some equations around. So you're going to want your x's and y's to all be lined up together. Step two, you're either going to add or subtract the equations to eliminate the variable with common coefficients. So remember, coefficients are the numbers in front of the variables. To make this a little bit easier, if they are opposites, so that's like positive and negative 5, you are going to add. All right, if you think about, if you do 5 plus negative 5, that cancels out to 0. If they're the same, so 5 and 5, you need to subtract to get rid of them. So if they're the exact same number in front of a variable, you have to subtract your two equations to get it to go away. If they're opposite numbers, one positive and one negative, then you need to add. All right? So after you add or subtract, one of your variables should be gone. So then you need to solve for the remaining variable. So then you'll get an answer, x equals a number or y equals a number. So then you will plug that number in, so substitute that answer into the another equation and then solve for your other variable. Again, in words it doesn't make a lot of sense, but once we do a couple of them, hopefully it will make sense. So when you're looking at number 1, we're going to do all the odds on this video. Your variables are all lined up. So it's just like when you used to stack things when you were doing like 523 plus 492. You want to make sure your things are lined up. So we have a 1y and a 1y, a 3x and a 1x. So our y's have the exact same coefficient, so we need to subtract. And you go straight down. 1y minus 1y is 0. You do need to write 0, not 0y. Equals 3 minus 1 would give us 2x. Here's where you have to be careful. 4 minus negative 2 gives me positive 6. 4 minus negative 2 really means 4 plus 2, which is 6. So now it's as simple as solving this equation for x. So I would move the 2x over. Negative 2x is equal to 6. Divide, x equals negative 3. So this way to solve seems a lot easier than substitution. All right, and for the most part it is. It's just when you plug it back in, it gets a little bit harder. So you can plug x equals negative 3 into either of your equations. I'm going to plug it into this one because it's a little bit easier. So y equals negative 3 minus 2, which is negative 5. And then remember, you need to write your answer as an ordered pair, x then y. So negative 3, negative 5 is your final answer. Again, plug negative 3 in for both x's and negative 5 in for both y's to make sure your answer actually works. Then we'll move down to number 3. These are already lined up. We have both positive 3x's. So those are the exact same, so we need to subtract. Same, subtract, opposites add. So 3x minus 3x. Here you don't have to write the 0 because there are other things left on this side. You can if you want, but you don't need to. You can show that they cancel out, but you still need to be able to use those equations later. So make sure they really do cancel out though. 3 minus 3 does give us 0. Negative 10 minus negative 9 gives us negative 1y. Again, if you want to put the 1 there, you can put it there. 14 minus 15 gives us negative 1. Divide, y equals 1. So again, that part seems easier, but now we have to plug that into one of our original equations. I'm going to pick the bottom one. So 3x minus 9 times 1 is equal to 15. Hopefully you don't have to write that step. You can just think, okay, this is a 1, so 9 times 1 is 9. So hopefully your first step could be just 3x minus 9 equals 15. Hopefully you don't have to write that step in. So add 9, 3x equals 24, divide x equals 8. So again, your final answer is the ordered pair x then y, so 8, 1. Number 5, they're lined up. Now we have positive 4 and negative 4, so those are opposites, so we get to add. So 4 plus negative 4 cancels out. So that's how that goes away. 9 plus 7 would give me 16y equals 5 plus 11, 16. Hopefully you don't have to show your division, but you can, and we get y equals 1. So I'm going to plug 1 in for this y. So 4x plus 9 times 1 is just 9. So instead of writing that with the parentheses, do that multiplication in your head or with a calculator. Is equal to 5. Subtract 9. 4x equals negative 4. Divide x equals negative 1. So negative 1, 1 would be your correct ordered pair. Obviously, it's possible to get fractions and decimals, but for our work, you should not. So you should only get integers. So if you do a problem and you end up with a fraction or decimal, then something went wrong. Number 7. These are lined up. We have a negative 1y and a positive 1y. So one's a minus and one's a plus. So those are opposites, so we add. So 1 plus 3 would give me 4x. The y's get canceled out. Oops. Again, I don't like to leave that canceled out there. 10 plus 18 is 28. Divide, and we get x equals 7. So again, the first step for these is simple. The second step is just a lot longer. I'm actually going to plug 7 into the bottom equation, so I don't have to divide by a negative 1. So 3 times 7 gives me 21 plus y is equal to 18. Okay, so if you're confused about where that 21 came from, 3 times 7 plus y is equal to 18. So hopefully you don't have to write that step out, but you can if you want. Subtract 21, y equals negative 3. So my answer, the ordered pair, is 7, negative 3. For number 9, this is our first one where it's not lined up. So the first thing you need to do is you're going to move the 2x over to this side. All right, unless it's like number 1 where it had y equals and y equals, you want your x and y on the same side. So to move the 2x over, I would subtract it. So write it right down here. Negative 2x, because I subtracted it, plus 4y is equal to negative 8. So now I'm going to ignore the top one. We'll come back to that in a minute. But now we're just looking at these bottom two. We have a minus 4 and a plus 4. Those are opposites, so we add. So 5 plus negative 2 is 3x. Our y's canceled out. 20 plus negative 8 is 12. So again, you don't have to show your division if you know that that needs to be 4. So x equals 4. You can plug it into any of the equations. It's going to be easiest, though, to go back and plug it into this original one. So again, you're plugging 4 that you just solved in for that x. So 4y equals 2 times 4 is 8 minus 8. 4y equals 0, so y equals 0. That doesn't mean no solutions. This step right here, 4y equals 0, means 4 times something has to be 0. Well, the only option is for that to be 0. You can also show that you're dividing by 4. 0 divided by anything is still 0. So 4, 0 is your ordered pair for that one. Our last one is number 11. Again, we do not have things lined up. So the first thing I'm going to do is move this 2x over here. So that becomes negative 2x minus y equals 10. To move that 2x over, I need to subtract it. Because I like things lined up, I'm going to move this one underneath. 2x plus y equals negative 10. Okay, so I just did that so that way I have them right next to each other. So this one, most people are like, well, what do I do? Because they both match. Well, just pick one. So I'm going to pick the x's because that's first. I have a negative 2 and a positive 2. Those are opposite, so I add. Well, negative 2 plus 2 is 0, but negative 1 plus 1 is also 0. So everything on the left-hand side cancels out. So I'm left with 0. So if you don't have anything left over, you do need to write a 0. Equals 10 plus negative 10 also equals 0. So we have things that are complete opposites of each other, so when we added them, they both canceled out to 0. This is a true statement, so we have infinitely many solutions. So you still can have infinitely many or no solutions. So if both of your variables completely cancel out, you're either going to have a true statement or a false statement. If it's true, then you have infinitely many solutions. If it's false, then you have no solutions.